Greetings, Chem students. This is Mr. Braun. We're going to work some examples of colligative properties. And just a little review, remember that the melting point depression is calculated by taking delta T sub F, the change in the temperature of the freezing point, is equal to Van Hoff's factor, I, times the freezing point constant times the molality of the solution. The boiling point elevation is the change in temperature of the boiling point is equal to Van Hoff's factor times the boiling point constant, K sub B, times the molality. So, when I come on to my first example, I'm going to pause the video here so you can write down the example. Welcome back, Chem students. The example says, what is the boiling point of a solution that contains 30 grams of sucrose, which is C12H22O11, dissolved in 100 grams of water? So like I said before, what I like to do is I like to write down my equation I'm using. I start off with the boiling point, Van Hoff's factor times the boiling point constant, not the freezing point, and times the molality. So, what am I trying to find? I'm trying to find the boiling point, so I need to have I need to have K sub B, and I need to have the molality. Well, Van Hoff's factor, this is a molecular compound, sucrose is. So Van Hoff's factor for any molecular compound is going to be 1. The Kb, the boiling point constant for water, is going to be equal to 0.51 degrees Celsius per molal. Where did I get that? I got that from the chart that has molal freezing point and boiling point constants on it. Final thing is I have to determine the molality. Well, I know molality is moles of solute over kilograms of solvent. So I've got to convert my 30 grams of sucrose into moles to start with. So I'm going to take that 30.0 grams of sucrose, which is C12H22O11, and I'm just going to work a flux capacitor problem. That flux capacitor problem will take it, let me extend the page here. That flux capacitor problem is going to take that to moles. So I had to calculate the molar mass, which I've already done. So I know that 1 mole of C12H22O11 is going to have 342.29648 grams of C12H22O11. My grams will cancel, so it's going to leave me a value in moles. Well, when I calculated my value in moles, it came up to be 0.08 0.08764 moles, and I need to divide that by kilograms. So I take the 1,000 grams, would be 1.00 kilograms. So my molality is going to be 0.08764 lowercase m. So now I need to just plug this into the equation. So I know that delta T sub B is equal to Van Hoff's factor, which was 1, times the constant for water, which is 0.51 degrees Celsius over molal, times the 0.08764 molal. As I can see, my molal is going to cancel, so it's going to leave me with degrees Celsius. And my final answer, well, not my final answer, but my change in the boiling point is going to be 0.044698 degrees Celsius. Now, I am not done, ladies and gentlemen, because that is the change in the boiling point. I need to find the original boiling point. Well, for water, it's really easy because water boils at 100 degrees Celsius. So if I would add that together, I would have my new boiling point to 100.044698 degrees Celsius. Now, we tend to not put significant figures, and I forget how WebAssign does it. They might tell you how far to carry it out, okay? But we do not put significant figures because if we would, I would have this being 3 significant figures, and that would read to be 100 and not 100.044698. So that's the reason that I did not sig fig my final answer. Now here is the second example that I'm going to work for you. So I'm going to give you a second to copy that. Welcome back, chem students. Here we go with our second example. What is the freezing point of a solution that contains 35 grams of aniline C6H5NH2 in 500 grams of benzene? So just a mental note here, we're not dealing with water. Our solvent is benzene. So that's going to be a tad bit different. Well, I know that I'm dealing with the freezing point. So delta TF is equal to Van Hoff's factor times the freezing point constant times the molality. Let me make that, that's kind of a, didn't look much like an F. There, it's a little better. So I have to find the 3 things. Van Hoff's factor. In this case, once again, I have a molecular formula, so it is going to be 1. The Kf, the freezing point constant, is going to be for benzene. So as I find my Kf for benzene, it is going to be 4.90 degrees Celsius per molal. The final point is to find the molality of the solution. Remember, molality is the moles of the solute divided by the kilograms of solvent. So I'm going to have to convert 35 grams into moles. So 35 grams of C6H5NH2. Do my flux capacitor. I know that 1 mole of C6H5NH2 has 93.12648 grams of C6H5NH2. My grams cancel. My grams have canceled. So my final answer is going to be in moles. So when I do so and get my final answer, I come up with a value of 0.37583 moles. So now I've converted that to moles. I've got to find my molality. 0.03037.583 moles over how many kilograms? It is 500 grams. So that's going to be 0.500 kilograms. So my molality is going to be 0.75167 lowercase m for molal. Plug it back into my equation. Delta T of F is equal to vent Hobbs factor, which was 1. Kf was 4.90 degrees Celsius per molal. The molality was 0.75167 molal. My molals cancel. It's going to leave me an answer in degrees Celsius, and that comes up to be 3.68. Now, once again, I am not completed because that is the change in the temperature of the freezing point. I need to go back and find what was the original value for the freezing point of benzene. And when I look at my chart, benzene freezes at 5.5. So what I'm going to do is I'm going to take 5.5 degrees Celsius and its freezing point depression. So I'm going to subtract 3.68 degrees Celsius. So my new freezing point is going to be 1.82 degrees Celsius. And that is my final answer. Ladies and gentlemen, this has been Mr. Braun working examples of colligative properties. Chem students, let's investigate.